Hello, Kirtana, I'm audible.
Yes, sir.
Okay. Yeah, Kirtana, so you had a test in a very recent time. Kirtana, you had a test in a very recent time.
Yes, sir.
Okay. Uh, what was your score? How was your marks in that test, whichever you had in very recent time?
I didn't attempt the physics parts.
You can tell me why?
Like I started the exam very late, so I didn't have the time to do.
All right. Which chapters were there in the test?
Sir,
Which chapters were a part of the test?
ray optics.
Have you done that chapter earlier?
No, sir, but I know a few formulas from it.
That's not a thing. You're studying in some institution or you're just giving tests from that institution.
I'm studying this.
So before taking your test, they must have taught you, right?
Yes,
Okay, still, so you should be knowing about the chapter. All right, Kirtana, we'll leave this part. Yeah. Which topic we covered in the last class? Kirtana, which topic we covered in the last class? I hope my voice is audible to you. So yeah, I'm asking which topic we covered in the last class. Kirtana, what happened? I'm not audible. Okay, waiting for the response because we'll start with the next topic. Okay, great. Now, look, can you hear me? Yeah, yeah. Okay, so I'll give you one problem, and after this, we'll move to the topic. Okay. Yes. So just don't take much time to solve this one. So the problem is given is so you are given an example. Basically, this example is a galvanometer of resistance G, which is shunted by resistance S. Okay, this is the thing. So we wanted to keep main current, keep main current in circuit unchanged. Okay, the resistance is supposed to be the resistance is to be put in series with galvanometer. Okay? Yes. So this is the problem, Kirtana, and I hope you understood the problem. If not, you can just let me know. Okay? The solution board I have given, but you have to solve this and get me the answer first. If you're not able to make it, I'll give the solution. Okay? This is given as shunt. Okay, so if you want explanation, there's a galvanometer which is having a resistance G, which is shunted by a resistance S. Okay. You wanted to keep the current in the circuit unchanged. Okay. What value of resistance you are going to put it in the series so that whatever the circuit, whatever the current was flowing in the whatever the configuration earlier was, it should be unchanged. Okay. That is what you have to calculate. So your answer will be in the form of G and S maybe. Okay. Maybe R can also be a part of that. So your answer should be a part of GRS. Okay. It will be in this form. So you have to give me the solution. Try it once and get me the solution. Time you can take at max maybe 2.5 minutes or 2 minutes. Okay, let's take. I'll give you 3 minutes. Okay, and I'll start the time now itself. Time started. Just solve it. Get me the solution. I have to start the next topic, and I wanted to complete this chapter by today. The time is just 1 minute more. Please solve it and get me the solution. Alright, Kirtana, your time's is up. Okay. So have you got the solution, Ketna?
No, sir.
Okay. Look, the problem is saying you had a galvanometer G, okay? You have shunted it, but you wanted to keep the current in the main circuit unchanged, assuming that initially you had a G, okay? You may be having some circuit. Assume this is the complete circuit, okay? Something was there. Some I current was ongoing, right? Now what you are doing, Kirtana, you are applying a shunt over here. Understood? Because of this shunt you when you apply, what will happen? Because this whole thing is going to get reduced because you are adding something in the parallel. It means there will be some change in the register. But you wanted to keep this main current as I. So can I say that Kirtana, it is asking me what resistance I should keep such that the whole thing by applying these two things extra, it won't change your circuits. Can I say the Kirtana? Earlier at this particular portion your net resistance was G, okay? So if somehow you can keep the G and S this parallel configuration plus this extra R, if the resistance of this whole thing come out as G, can I say the Kirtana I will maintain my current I?
Yes.
Can I say this Kirtana? Okay, so this is the only thing we have to do. Can you solve this now? Okay, let's leave it. I'm already doing the solution. Okay, so I wanted to do G should be such that G parallel S plus R, and we know how to calculate this G parallel S. GS divided by G plus S plus R. This is the value I need to calculate. So what is this? R will be nothing but GS, okay, sorry, S plus. So this is what the value is going to be. Okay, so this comes with as G square plus GS minus SG divided by S plus. So Krishna, this is the value. Is it clear? In better note, these two are going to get cancelled. So R will be nothing but G square divided by S plus G. Okay. Is it clear, Kirtana?
Yes, sir.
Any doubt?
No, sir.
Uh, okay. So it's uh, after this we can start with Wheatstone bridge. So, Kirtana, do you know what is Wheatstone bridge?
Yes.
Okay, what is it?
P by Q will be equal to R by S, then the
Wait,
resistance in between is in.
wait. I'll be writing this equation. This is P. This is R. This is assumed to be the galvanometer. This is P2 okay, this is assumed to be the circuit. Okay, so I'm saying this is a part of Wheatstone bridge. To make it Wheatstone bridge, Kirtana, perfect balance Wheatstone bridge. What should be the ideal condition? What should be the condition such that I can say this is a Wheatstone bridge? Yeah, Kirtana, what do you think?
P by R is equal to.
Wait, just think of it again and let me know the answer. Kirtana, you said you know what is Wheatstone bridge, but you don't know what is the condition for balance Wheatstone bridge. How it is going to work? I won't be giving you the complete derivation of the Wheatstone bridge again, but yes, I'll explain it once again. Wheatstone bridge. Okay. What this bridge says that by the name you can think of it something called bridging, right? I'm talking about some bridging thing. Can I say this? I'm looking for something bridge kind of thing in my circuit. So what I will be doing ideally, let's assume this is terminal A, this is terminal B, this is terminal C, this is here's my I whatever I could remember, I gave you I have already taught you Wheatstone bridge and I have already taught you 3 to 4 configuration of the Wheatstone bridge. How we can make different kind of Wheatstone bridge. Could you remember that? Could you remember that we have already studied 2 to 4 types of Wheatstone bridge? Okay. Okay. As per the Wheatstone bridge, if P by Q is equals to R by S, basically the adjacent one, either this by this, either this by this. Okay. If you are taking this by this, take this by this. If you are taking this by this, then you have to take this by adjacent ones. Okay. If adjacent ones are common, like they are in the relation, then you can ignore the current from here. You can say the I is going to be zero. Then I will be zero. This is what the Wheatstone will says. Clear? The only thing is about the Wheatstone. All the derivation is a little bit vague. We have already done this part, so I want to think again. There's a 2 more measuring instruments are there, okay, which we have to discuss about. So yes, Kirtana, if you don't have any doubt again in this one, so I will move to the next part. Is it clear? Okay, I'll give you one problem.
Yes.
We have studied this capacitor part also, so you should be knowing about this also. Okay. What you are given? You are given basically you're given this is R1, this is R2, this is C1 and C2. If galvanometer shows null deflection, shows null deflection. Here's now what I meant by the null deflection. Look, what is the use case of this galvanometer? I can measure the current, right? If it is showing null deflection, mean to say it is not moving. Null mean to say if this is a point, it is still at the zero. Okay? It is not moving. So it means the current in the circuit is zero. Null deflection. Then the option, the which option is correct? Then the correct option is your options are R1 by R2 is equals to C1 by C2, B R1 by R2 is equals to C2 by C1. Here you can write ABC. Right? C will be nothing but R1 by R2 is equals to C1 square by C2 square. B is equals to R1 by R2 is equals to C2 square by C1 square. This is what the Kirtana you had explained. So Kirtana, please solve it once and get me the answer. Assuming that current Q is going flowing in this way, okay? It's going in this way. Yes, Kirtana, just try to solve this and get me the solution fast. Kirtana, just solve this one, get me the solution fast. If you don't know, just directly tell me don't know. Okay? Don't waste time. Put the time on it will be much better. Yeah, Kirtana, so you have 3 minutes. Solve it. Shit. Okay, good. That's actually correct. The answer for this one is option B. Okay, makes sense. Okay, good. Now I'll be moving to the new topic itself. That is measuring instrument. Basically, in the measuring instruments, we have done the galvanometer. Rest of the two topics in the galvanometer. Now the main topic is this one's main topic actually. The topic of discussion is meter bridge. Okay? Something called meter bridge. What is a meter bridge? Look, Wheatstone bridge is one of the important principles. The rest of the two, one is meter bridge, another is potentiometer. Both are going to work on the principle of this. Okay. So what we say here, now, we are having a strip like this. First, I'll be making a diagram for this one. This is a wooden part. Okay. This whole thing is a wooden part. In this wooden part, this is a metallic portion. This is a metallic portion. So here you are connecting a resistance R. Okay. This is a resistance R you are connecting. This is another metallic portion, other metallic portion. From here, there's a already connected S part. You can, okay, I'll assume this to be S. Then, Kirtana, the main crux is There's a point in the center. Okay, the whole thing. All these points are connected. Okay, all these are points are connected. So what you can say is this is connected with a galvanometer G. Okay, and it has a pointer. So this pointer can slide over there. So here you have. Okay, I'll just make it quite. Assume this to be a bigger scale, 100-meter scale basically. That's why we are naming it as a meter bridge. Okay? The length of this is from 0 to 100. Maybe this is 0, then 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. Okay? Finally, so basically 100 centimeters. Clear it now? This is of 100 centimeter on an average. And there's a you have the galvanometer G, and it has another knob very big. Okay? This pointer can move from here to here, okay? In the whole bridge. Now, Kirtana, the point is why we are using this. What is the basis of this? If you see, Kirtana, this whole thing is a wire, right? The whole length is a wire itself. Assuming the whole thing is a wire, if there's a wire, a very long wire, basically this is 100-meter wire, maybe like this, it has some resistance. Resistance depends upon two things. So you can say the Kirtana resistance of this part and resistance of this part is different because that will depend upon the length. If I say this pointer is touching this point, so if I say this is a L length, so what will be this length? The rest of the length that will be 100 minus L because the total length is L. Kirtana resistance. If I know the total resistance of this, assuming the total resistance is R, so what is the resistance of this portion, the L portion? You can say resistance is basically raw L by E. What is the resistance of other part? That will be R dash. That will be okay. The other part that will be raw 100 minus L by E. Okay. This is the thing. Clear? If you divide it, what you are going to get cancel. No, sorry. Yeah. These two things are going to get cancelled, and what you are left with R by R1 is equals to L by 100 minus L. Okay. This is one thing. All that is this part is not that necessary. It's removed for a while. Kirtana, just look at the image and tell me whether you understood the mechanism of this meter bridge, how actually it is looking like. Look, our task is task given R non-resistance. This R value is not true, okay? You can actually change it by yourself. R is non-resistance and S is unknown resistance. S is unknown resistance. You need to calculate a non-resistance. You need to calculate. Compute the value of S. Okay, Kirtana. So, Kirtana, if I wanted to calculate, do you know, Kirtana, if I apply a battery along with it, assuming this point I am connecting it with a battery, assume this to be a battery itself. Assume I have connected the whole thing with a battery like this. So, Kirtana, if you see carefully, what will happen? Because there is a battery having B, it will go. It will provide some current. This current will be distributed this part and it will be going this point, then this wire, then this wire. Kirtana, if you see carefully this point is actually connected with this. These two are connected and this, okay? This is internally connected. Although this is a wooden metallic strip, okay? This is a wooden strip. This part is a wooden strip, wooden strip, okay? This is internally connected, internally connected, okay? So what will happen, Kirtana? If you just take all this, look, can I say there's one resistor R, then this resistance is connected with the point. Assume this is the point. Then from this point, one galvanometer is there because you can see this is galvanometer G. Then another point is going to S. another distance s. Okay, this is the thing. Acha. What about this part? The other point of this S is going to be connected with this particular point. Okay, I said this point. This point is now going with this way and again connected with this particular point. That is another point of R. So assuming this is the RL. Okay, I'm saying RL. What is RL? Resistance of this part. Okay, and the other part is R 100 minus. Okay, is it clear, Krishna? Can I say it is kind of Wheatstone bridge? I can see. Is it clear, Krishna? Can I say it is acting as a Wheatstone bridge?
Yes.
Okay. Now, how we are actually going to figure out the value S? This is basically an experimental setup here. Now, what we are going to do is, look, because you have applied some current, you know, when you are having an unbalanced bridge, if the Wheatstone configuration is unbalanced, if Wheatstone bridge is unbalanced, what will happen, Krishna? Unbalanced current will be flowing through galvanometer, right? Flowing through galvanometer, in galvanometer, right? But when this configuration galvanometer, when this configuration is going to be okay, when it get balanced, when it gets balanced, Ig will become zero. At that point, I can say this is a balance. Okay, how we are going to do? Uh, do I have to change the value of S or R? No. What I'm going to do it now, you can see if I change the value of L. Okay, let's look at this case now. R is constant. R is constant. What is the next part? RL and R 100 minus L. Okay, let's look at this. Hmm, okay, because Krishna, I need R by RL should be equals to RS by R 100 minus L. Right? So what I should do, you know that we have already calculated that RL is nothing but raw L divided by A. Raw 100 minus L is equals to, what is it? Raw 100 minus L by A. If you divide it, what you are going to get? RL divided by 100 minus L. That comes out as L by saw minus L. Okay. This is what I will substitute it. If we substitute this, what you are going to get? R divided by S is equals to RL divided by 100, R 100 minus L. This comes out as R by S is equals to L by 100. From where I have got this equation, I have got this equation from here. Now, how you have to figure out the value of L. How you are going to figure out the value of? We can see I can get the value of S. I had to calculate S, right? So, what is the value of S? S is nothing but 100 minus L multiplied by the given resistance divided by L. Now, what is this L value? Look it now. L is some certain point, because if you start moving from here, okay, change it. The moment you see that galvanometer comes up at rest, there is no deflection. You can say this is my L. Okay, is this clear, Krishna? Have you got the construction of it? How it is going to work?
Yes.
Okay, this is all about the galvanometer. Okay, it works on the principle of balanced Wheatstone condition. It works on the principle of balanced Wheatstone condition. Clear? Any doubt, Krishna?
No, sir.
No doubt, right? Let's try to get a problem for you. On the basis of this Wheatstone bridge itself, and by this we'll be done with the Wheatstone bridge. Just some problem practice part is left. No problem. Sure. S- So yeah, Kirtan, I'll place you one problem. So we solve this and give me the solution for this. Yeah, Kirtan. So yeah, this is the form. Right? You can try to solve the problem. You can rewrite this thing. If I solve this, after that we'll move to the next topic. That is potential. कितना have you solved it? Hello, कितना have you solved this one?
Is it 50, sir?
No, it's not 50. It's 40. You could have told me that you have solved it or not. Look, you are given a Wheatstone bridge arrangement, resistance XYR, using two gap of a bridge. You know, when you make a bridge, you don't have to make a complete bridge, okay? Whenever you're making, just simply, you will be applying something over here, okay? Then it will be something over here, and then the whole length is there, right? Something like this. So this is 100. So, yeah, this is. So, null point is detected at a 25 centimeter. Mean to say, at 25 centimeter, you figure out a null deflection from one end of a wire. Okay, look, one end of a wire. Maybe assuming this to be the end from here. Okay, and you are also given that y is greater than x. So assuming this side to be greater than x, okay, that is very simple. If the resistance of 2 is x, okay, instead of x you have used 2x. Assuming this was x, this was y. If I instead of this, if I have used 2x, then you have to calculate the distance of a null point. You know, Kirtan, the x by y was initial condition, it was 25 by 100, right? Okay. If instead of this, if I would have used, what is this formula? This comes out due to L divided by 100 minus L. Okay. Instead of this, if I use what 2 times of x divided by y, so what I would be getting L divided by 100 minus L. But I know what is x by y. This is nothing but 1 by 4. So if you just keep 1 by 4 over here instead of this, you will be getting 1 by 2 by 4. 4 yes. So it will become 1 by 2 is equals to L divided by 100 minus L. So yeah, this whole thing will be coming out as 2L is equals to 100 minus L. So this goes here, 3L is equals to 100. This is 100. So this comes out as how much? 100 divided by 3. This is what coming out. Yeah, this is actually what coming out over here. Okay, Kirtan. So this is 3L is equals to this. No, wait. It should not be this thing. 3L is coming out to be 100. Is it for you? Okay, yeah, there's a small mistake we did. Because we have already utilized 725 centimeters, so the rest one is not 100, the rest one is 75. Okay, so yeah, it should be actually quite, it is incorrect. It should be 25 divided by 75 because 100 minus 25 should be there, right? So this comes out 3 by 4. So here you need to keep, instead of x by y, you need to give 3 by 4. Okay, now you will be getting, no, actually it should not be like this. Sorry, it will be 1 by 3. Okay? So this comes out here as 1 by 3. We'll write it. Yeah, this comes out as x by y in the new case. What is the new one? But we know x by y already. What is it? 1 by 3. So 2 by 3 is equals to L by 100 minus L. So if you solve this, 200 minus 2L is equals to 3L. So L goes that way 5L is equals to 200. So new length comes out as 40. This is the correct answer. Is it clear to you now?
Yes.
Okay. So should we go with a new topic or cover some more problem practice for these particular topics? What do you think, Irfan? Should we discuss one on more problem or we should discuss a potentiometer and new topic itself? Look, basically potentiometer is also based on this topic itself, okay? By using potentiometer, we can calculate external EMF, we can calculate the external resistance also. Okay? These things we usually do in that case. So it's your choice, like whatever you want me to cover up, I'll cover that. Okay. So yeah, just let me know which topic we should to cover. Okay. Um, it's already 10 minutes we have left, and we actually can't do a new topic. I'll be giving you mm, one more problem. Okay, you can take and solve. Try to solve it. Get me the solution. Okay, it will be much better. I will suggest you to try a potentiometer by yourself. Okay, if you can do it by yourself, I don't. I think I won't be needed to cover it. The only topic is left. Okay, Kirtana. If you can do the potentiometer by yourself, I will start the magnetism chapter from the next class. We have to cover things a little bit fast. Kirtana, try to solve this. Great, now we got the solution for this one.
There is R1, 2 and R2, 4.
After applying the given condition, are you getting the same answer? So, okay, now how much you have got? 2 and 4, right? Yeah. So for this one it is 2, for this one it is 2. Okay, do you want solution for this one? I'll just do it. Solution is very simple, Krishna. The R1 is was there, okay, and R2 was here, and there was a G over here. So this was a quite condition. Okay. Earlier, null point was at 1 by 3. It means this is the whole total 1 by 3 of the total. What we are left with 2 L by 3, right? Very simple, Krishna. R1 by smaller length ratio is equals to R2 by 2 by L by 3. It is already mentioned that they are saying if the resistance of 6 ohm is connected to series is smaller. You can say that this is smaller, this is smaller. If they both are equal, it means this must be smaller than this, right? So we can say R1 is smaller. So if I am adding R1 plus 6 ohm resistance, okay, then the null point is coming up with this. Okay, makes sense. So what happens now? R1 plus 6 ohms divided by 2 L by 3 plus should be equals to R2 divided by L by 3. Just cancel the things, cancel the things. What you are getting? R1 plus 6 is equals to R2. From here, what you are getting? Cancel, cancel. Uh, R2 is equals to 2 times of R. Okay? So this is what you are getting. So when you substitute the value, R2 is equals to 2 R1. R1 6 is equals to this. Wait, one minute. We have made a mistake over here. I actually don't think so, but this. Uh, okay, this is plus. So if this goes that side, so R1 becomes 3. No, R1 becomes 6, right? Why I'm getting R1 is equal to 6. Okay, what the problem saying? If resistance of 6 ohm is connected, the series with a smaller resistance, right? R1 is the smaller one, so ideally I should keep 1 by 3. The total length I'm assuming to be 1 by 3, but the total is L minus L by 3. So that should be that thing itself. So I am getting it incorrect. Wait. Yes, 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 yes. It was 2 also, right? This 2 should go here. So it will become 2 times of this. So this becomes 2 into 2. So this whole thing come out as 3 times of R1 is equal to 6. So R1 will become 2. Okay, now it's fine. So if you again substitute the value, you are going to get R2 is equals to R1 plus 6 8 by 2 4. This is the answer. You have already got that. Alright. Any doubt, Krishna, for today's session?
No.
No doubt. Okay, Krishna, one more thing. Can you do the potentiometer part by yourself?
I'll try.
Okay, just try it once. Okay, if you are not able to do it, we will do it in the next chapter. If you are able to do it, then we will directly shift up to the next chapter. Okay, that is magnetism. All right.
Okay.
Before this, apart from this, even if you are not able to solve the like potentiometer part, don't worry. Before the next class, just to confirm, just confirm that Are you clear with all the concepts from the previous chapters till here? Whatever we have done so far, you should be clear with this before moving to the new chapter because you have already done three parts, very basic or big chapters. Okay? Next chapters are not going to be that big. So yeah, you should be clear with the previous things before moving to the upcoming part. Is it clear? So yeah, that's all for the today's discussion. All right, Kirtana, you can I'll end the session. Good.